Okay, let's continue with this question. As you can see, the wooden block is here, and there's a Bunsen flame heating the metal rod. So the metal rod will gain heat and expand, right? Okay, do take note, this section, the arrow actually is stuck onto the metal rod. Okay, there's no pivoting. Okay, so when it expand, the whole arrow will move vertically this way. Okay, so they say, what will the arrow point to? Does it which alphabet? Okay, which alphabet will the arrow point to when the metal rod is heated after some time? So the answer should be point to R, right? Okay, point to R after some time. Because part B, you explain, the metal rod gain heat and expand, causing the arrow to move to the right. Okay, causing the arrow to move to the right, or move to R, sorry. So the answer should be this way. Maybe I put it here. So the metal rod gains heat and expands, causing the arrow to move to the right towards R. Okay, so this is the answer. What does this experiment show? Actually, very easy. It shows that metal expands when heated. Okay. Because now they are heating metal. So this experiment shows metal expands when heated. Okay, clear this one, easy. So I'll screen share this and send to you all shortly. So under the chat there, you take note, under the chat, I will screen share this to all of you. Screenshot too. Okay, next. Next question. Okay, describe briefly how each of the following problems. Okay, this one you talk about problem. It's not talk about what causes them, how to overcome this problem. Okay. So the concrete path cracked under the sun. So remember just now earlier the multiple choice question, right? So we leave a gap, right, in between. So we can say install expansion gaps or leave a gaps between the concrete paths. So for this question, okay, this is how you answer for this part. If you put install expansion gaps in between the concrete slabs. Okay. Install extension gaps in between the concrete slabs. Okay, same thing MRT track as I told you, right? So the same thing, install expansion tracks. Install expansion in between the tracks. Okay. Next one, telephone wire. Install wire with some slack, as I told you earlier in the MCQ, right? Okay. So install wire with some slacks between the poles. So again, I will snapshot this and send to everyone in the chat. Okay, so we've gone through. So Anna, you just came in. We are at question 7, page 9 of the worksheet. Okay, next. Okay, this one I have written down a hint there. If you see carefully, there's a hint saying that fizzy drink. Fizzy means those carbonated water, right? Like 7-Up, Coke, Coca-Cola. Okay, they actually contains dissolved carbon dioxide. So when you see such questions, it's good to annotate. So you annotate the hot water here. Okay, and this one you note right by the side. Fizzy drink contain what? Dissolved carbon dioxide. So carbon dioxide is a gas. So when you place this in the tub of hot water, the fizzy drink will gain heat. Okay, this will cause the dissolved carbon dioxide to expand, right? So they say, what will you observe when it's immersed in hot water for some time? So this cork stopper will be what? Okay, will be removed, will pop out. So you mentioned the cork stopper will pop out. Okay, for this one. So the cork stopper will pop out. Then you explain the observation. So you should say that the hot water heats up the fizzy drink, causing the carbon dioxide to gain heat and expand. Okay, this part. Hot water heats up, causing the dissolved carbon dioxide. Dissolved carbon dioxide to gain heat and expand. Okay, the pressure in the box, pressure inside the bottle increases, and the cork stopper will be popped out. So take note of this. I will snapshot this and send to you shortly. Okay, sent. Okay, so you take note of this. Okay, next. Which of the following, the bottle, liquid, or gas in a fizzy drink expand the most? So if you have paid attention earlier, right, I told you gas expand the most, right? Yeah. So it's the gas in the fizzy drink. Because gas does not have definite shape. So it gains heat easily and it will expand the most. Okay. So it's the gas in the fizzy drink. Okay, next, which expand the least? Of course, is a bottle. Bottle is a solid. Okay. So the last one is the bottle. So same thing, I send this and send to every one of you. Okay, this part. So I've gone through this part. Okay, this question, this is a test tube. There's air inside the test tube. And then there's this this hollow maybe tube, right, or straw, has a drop of colored water inside. So you're supposed to describe and explain. That means you must mention what will you observe. Initially, means at first. So let me explain this. So you can actually, what you draw is you can try to annotate this in a beaker, right? So there's water inside. Okay, the water inside here. And maybe it's hot water, right? You say hot water, right? Okay, maybe it's at 81 degrees Celsius. Okay, so this hot water, because the first part that is in contact with the hot water is the test tube surface, correct? Which is a solid. So this surface, right, would gain heat and expand. So when it expand, it will allow, that means this part, right, that there's more spaces. So initially you will see the droplet of water drop a little bit, maybe like 3 mm, 3 millimeters at first. Okay, because the test tube test tube gain heat and expanded faster than the air inside. Okay, because the air is being separated by this test tube. So the test tube actually gain heat first. So there are two things to write. Firstly, you must mention the drop of colored water drops slightly. Okay. This answer. the drops of colored water drop slightly. Okay, the reason is because the test tube expanded faster than the air inside. Okay, so you take note of this. The test tube expanded, the drop of colored water dropped slightly. The reason is because the test tube expanded faster than the air inside. Okay, next, this going to explain what happens next after the initial observation. Okay, the question, does the air expand more than a test tube? Okay, after that, yes, correct. After that, yes. But initially, it's because the test tube is in contact with the hot water. That's why at first, this one we do not know how long, because it depends on the amount of water. Also depends on the surface area in contact with the test tube. Okay, so this question is a bit tricky. You need to know that at first, right, the test tube will expand faster than the air, because inside, right, as you know, air is a poor conductor of heat. So the first thing here that expand is the glass tube or the test tube. But slowly, when the heat is being conducted inside, right, the air will expand faster than the test tube. That's why you see the next question, right, is the colored water would rise. Okay, the drop of colored water would rise because the heat, right, has reached the air and it caused it to expand more than the test tube. So Isabella, you asked me the right question. So this is the second part. So you mentioned the drop of colored water rises. The reason is because the heat reaches the air and it expands more than the test tube, or expand faster than the test tube. Okay, more than can be expand faster and it expand. Maybe you put faster, expand faster than, expand faster, causing it to rise. Okay, then thirdly, describe and explain. Okay, now you switch it. Now it's hot water, right? You switch to cold water. Okay, the cold water, the same thing will happen because they say initially. Okay, can you see the word initially? So cold water now reverse situation. So now the test tube, right, would lose heat faster than the air inside. So the test tube will string. So when it will string, right, it will press, this thing will go out. Okay, so this one is the drop of colored water will rise because the test tube contract faster than the air. Okay, so you take note this part. Okay, the drop of colored water. Okay, the drop of colored water would rise because the test tube contract faster than the air inside. Oh, this question, take note, a bit tricky. But it's good that it appears here rather than you get stuck in an exam or prelim. So I purposely choose this question to help you all. Okay, next. What does this experiment prove about contraction and expansion of different states of matter? Okay, this question a bit tricky. Okay, put a star here, asterisk. Okay, what do they mean? Because you see the test tube is solid, right? The air inside is gas. So now they're asking you, from what you've seen here, right? What you have seen, okay, what does this experiment prove? Does it mean what does this experiment show about how solid and gas behave in terms of contraction and expansion? Okay, so actually you can see that solid, right? They expand faster than gas, but the gas expand more than solid. So there are two things. One is involved the speed. One is in terms of volume. Okay, so this one I help you. You all write down this question, this answer here. This one a bit tricky. So you mentioned this. Solid expand faster than gas, but gas expand more than solid. okay, more than solid. That's why after a certain time, right, you see the colored water rises more than it drops initially. Okay, so you take note of this. Is this a PSLE question? Okay, PSLE actually, this is under the topic of matter plus heat combined together. I do not know whether this question came out in past year PSLE, but I have seen such question in prelim paper. Yeah. How many of you have seen this question before? This type of question. Maybe you can put in the chat there to let other people know. Because some student asked me whether this is. So Shrira have seen this question. Shrira say yes. Yeah. Okay, you're seen in P5 SA1. Okay. Is it in your school, Shrira? Or maybe when you answer question, you can share with the whole group so that people know that such questions do appear before. Okay, so this is the relevant questions that has appeared in some test paper before because it's related to matter, M-A-T-T-E-R, matter and the heat topic. Okay, next, what can be done to ensure the drop of colored water drop less initially when placed in hot water? So that's mean they refer here. Because the colored water drop, right? But it dropped a little bit. So now they ask you, how can I prevent it from even dropping? Okay. How to prevent it, right? To drop even less. So you notice here, right? It's actually why the thing drop, because of this thing here. Because the test tube, right? The test tube gain heat first. Then after that, the heat is being conducted into the air. So to shorten this waiting time, right? This transition from the heat from the test tube to go inside, right? Do you think I use a thicker test tube or a thinner test tube? I want the heat to be conducted faster to the air. So definitely I should use a thinner test tube. Okay. So you can say use thinner glass for the test tube. Okay. This part here. So this one is use thinner glass for the test tube. So take note of this. I will save this. Okay, maybe I mark use. Save. Send to everybody. Okay, clear. Okay, next question. Okay, state a function of thermostat. So the question 5, right? The MCQ is a device with switch on and off a circuit when the desired temperature is reached. So this is a function of the thermostat. Okay, a device which switch a circuit on or off when the desired temperature is reached. Okay, what physical property? So this is due to the different rate of expansion of different matters. Okay, so the property is this one, different rates of expansion of different matters. Okay, so now this is a circuit diagram of a bimetallic strip, electrical supply heating coil. So they say describe what will happen when the desired temperature is reached. So you just say that the bimetallic strip will bend away from the contact and break the circuit. Okay, now you see this part, right? Is in contact. That means it's a closed circuit. So they will keep on heating. So when they reach the desired temperature, okay, you mentioned that the bimetallic strip will bend away from the contact. That's mean, if you observe this, right, this will bend upwards, this one. Okay, that means strip B expand more than strip A. So they will bend upwards. So they will form there's a gap in between here. So the electricity cannot flow through here. So that it will stop heating. Okay. Now they ask you, suggest the methods for A and B. Okay, so I want B expand more, right? Remember just now the previous question. So B should be brass, right? And A should be iron. Okay, because you know initially there's one question. So strip A is iron, strip B is brass. Okay. So this part. Okay, done. Hey, this isn't done already. Very good. Finish. So you take note of this. So this paper, I've gone through this one, and this one. Okay, I would pause the recording and then continue to the next paper.